for coming over. So we have just half an hour. So what I'm going to do is I'm going to just jump right in, and each panelist can introduce themselves first of all and kick off.
Brilliant. So welcome to everybody. So my name is Pete Cooper. I'm an independent cybersecurity advisor and strategist based in London, but I'm also a non-resident senior fellow at the Atlantic Council, and that's where my relationship with the aviation cybersecurity and Thales sort of came about, because I wrote an aviation cybersecurity report last year to sort of spark some of this dialogue. In the Atlantic Council, we look at cyber statecraft, challenges for cybersecurity and cyber safety. So I'll pass on to my sort of colleagues.
Hey, so I'm Nathalie Fate. I'm working as a design cyber authority in Thales Avionics. What does it mean? That means that my role is to put cyber in every bit of our avionics systems, which is all the electronic you may have in the aircraft, in the cockpit and the cabin side. Okay, I've been always working in security. I began in Gemalto 10 years and moved to Thales, first in defense, now in avionics. So.
Stéphanie Perrat, engineering background, working 5 years, starting to work in a safety management system, and then move into Thales Avionics for supporting in the airline in efficient operation.
So last year, the Atlantic Council invited me to write the report, look at aviation cybersecurity. So my background is both pilot and cyber and cybersecurity. And really what they were looking at is, at the moment, the aviation industry is in a really good position of both strength and safety. So it's growing and it's as safe as it's ever been. But in the middle of this growth, there's been an increase in connectivity and digitalisation going on across every element of the industry, whether that's aircraft, airports, the management of it, or the supply chain of building the aircraft as well. And previously, a lot of the security in the industry was quite was there through just it was an isolated system, or it was a very bespoke system, so therefore the attack surface was very small. But now, with pretty much everything being connected, the adversarial opportunities are increasing fairly exponentially. And aviation has long been a target in the physical domain. So now what we've done through connectivity is maybe increase potential there. And the challenge as we move forwards is going to be, how do we maintain that reputation for safety and that reputation for security that the aviation industry has done so well in curating over the years. Because every other connected industry has suffered challenges through connectivity and digitalisation. How does the aviation industry move forwards with this? And there's that big drive for that digitalisation and some of the benefits there. So, Natalie, do you want to kick off and talk about where this drive is coming from? From the aviation, Stephanie, sorry. Where is this drive coming from?
Okay, first of all, you're right. Digitization of aviation is, of course, an opportunity that will enable the airline, but also all the ecosystem to ease congestion and also to transform the passenger experience by providing customized services. We see that the connectivity and the digitization is raising for the passenger, maybe in the cabin. We are now we are able to have connectivity and watch TV or having internet in the cabin, but this is not today in place in the cockpit. You may know that cockpit has very limited connected capabilities, and of course airlines are looking in the future to take benefit of this real-time connectivity by, for example, providing real-time updates of weather information to the pilot to fly safely and efficiently. Around the aircraft, of course, the staff, the maintenance staff, could benefit also about this connectivity, because they could take advantage of having remote capabilities to better anticipate or to better respond to operational interruption issues, for example. So this digitization will slowly enter into the operation, addressing all end users and stakeholders of the airline.
So from that sort of perspective and that growth and that desire for digitalisation, how is the wider aviation industry responding to that in trying to be able to produce it securely and resiliently, but actually respond to that need?
When I discuss with airlines chief information security officer, for them it's like if their information system is now extending to the aircraft, and the aircraft is an internet, an IoT in fact. And what they really like is to be capable to manage their information system up to the aircraft the same way they are managing their information system for, I don't know, passengers booking or flight management, things like that. So to answer that for us is a challenge, because we need to move from some technologies which are bespoke technologies that we have in the cockpit for the moment, and to connect them with standard technology, which are those used in computer science. And really, this is the evolution for our engineering to keep our safety by design objectives, as mentioned by Pete, and now to merge and connect with completely IP and internet open technologies. This is the point.
So with those benefits that are coming in that we've already started talking about, whether it's greater satellite communication, GSM now on board the aircraft or even built within the engines, Wi-Fi and everything, the attack surface that we're now creating in the industry is becoming exponentially large. And with adversaries now that increasingly they're becoming very capable, at the same time as their ethics are becoming increasingly more questionable. This is creating a real sort of challenge for the industry. So now we're looking at how does the industry move from being secure to being resilient, because of the nature of that risk management perspective. So if we're looking at balancing safety and security, is that something that the industry are really getting to grips with, between the safety, security and resilience of this challenge?
So the industry and the airline specifically are looking to these both aspects, security and resilience, because they are aware, and we are aware, that cybersecurity is not a state. In fact, it's a continuous process where we need to have a risk assessment, where we need to detect threats, where we need to be protected, where we need to put in place remediation plans. So everybody needs to be prepared. Airline needs to be prepared too. I will let Nathalie comment on how the industry is getting prepared, but from an airline point of view, they really need to shape their own business to cyber readiness. They will need to put in place either organizational mechanism, that we need to adapt the operational processes and practices, for example, by training the crews and the staff to make them aware that it does exist, and how to react to vulnerabilities, to threats, to be able to respond quickly to those attacks. But they will also need to formalize a risk assessment, like they did for years by running the safety management system. So cyber will come into the safety management system of the airline, and will be treated and behave the same way they do for safety.
So one of the ways to try and get people thinking about it, and I've used before, is speaking to somebody who works with satellites, is that don't think of it like a satellite, think of it as a node on your network. When you're thinking about UAVs, don't think of it as a UAV, think about it as a node on your network that you have to protect and you have to understand. Are we getting to the extent that actually we can really start to understand these nodes across all of the networks that is now the aviation industry? And can we have enough visibility, and can we risk manage all of those nodes?
Yes, as mentioned by Stephanie, this industry is really working on two pillars. The first one is safety, and the habit in safety is to have a safety management plan where you list all the potential risks that were failure originated, and now we inject into this list of risks causes that could be cyber causes. And what is good is the effect. If the effect is, I don't know, you want to shut down as an attacker on a flight management system, this is already an effect that we think about in terms of safety. So that means that we really benefit from these safety design principles. For example, our systems are there to continue working even if there is an error that occurs 10 to the minus 9 that demonstrates the high level of quality we have in safety design. But security will not be what we call security for safety, but also there will be an operational impact. How can I illustrate that? For example, a US company had troubles with their EFB systems. So you know, it's the pilot tablet. It's just there for digitalisation to replace document checklist to an application in a tablet. But what safety is saying, if you don't have your documentation with a clear checklist, you cannot fly. So they had a trouble issue, I don't know, computer issue on them. So they were obliged, mandated to ground the aircraft. So you see the second pillar. The second pillar is operational impacts. So it's where we need to help airlines in identifying all the risks they may have in their business for their passengers, but also for their business in running the aircraft and their operations.
So in managing those risks, I mean, the aviation industry is a highly regulated industry. So how do we, with the rate of evolution of change and the rate of evolution of adversary, how can we balance, in order to show and demonstrate security, how do we balance regulation with pushing improvement, and also the requirement from the airlines to have improvements? What's the balance? How do we do that? Either of you.
You go for regulation?
Yeah, I go for regulation. So regulation today is completely including security. That means we have a security for safety requirements that are there for about 10 years now. So, which is good because in safety regulation, if there is a critical field event, then you have 48 hours to tell to the authority, and then there is an inquiry, and we are mandated, whatever the cost. The cost may be 1 million euro for some line of codes in a safety critical calculator, for example. But whatever the cost, if safety is a concern, we will enter into quick reactions so that the aircraft can go on with their mission. So we'll do the same for cyber.
But what you were saying there about to demonstrate for a safety critical system, you have to be able to demonstrate 10 to the minus 9 chance of critical failure. I'm not quite sure at the moment how many cyber security systems or connected information systems we can demonstrate are secure to 10 to the minus 9. So it's an interesting challenge that we're facing, because some of the complexity of the systems as such and the adversaries as such that will be difficult to balance or find or set?
Yeah, in fact, you're right. We need continuous security on cybersecurity systems. That's why all the architecture of the aircraft is divided into layers from the more critical system to the less critical system. And the less critical system, for example, the cabin system, will be certainly the more connected at the time and benefit from, as I mentioned, standard technology. So we can have a rapid evolution time on those systems to perform our continuous cycle of upgrading, protection, having detection, and upgrading again. So the architecture is done so that if the first layers are falling down due to a cyber attack, they will be rapidly upgradable. Then if you go to in-depth layer, it will be longer. But at the full end, we'll go back to standard safety critical ways of working.
So your point there about the industries moving away from declaring absolute security to building resilience and building layers of security that at some point the adversary will be stopped before they get to critical. That's for example the airline industry moving from saying we are secure to we are resilient. Is that a mindset change, or is that something that is realistic?
No, it's coming. It's realistic, but the airline will also need to change their mind, of course, and to build trust like they build trust for safety. They will need to build trust for cyber. Now safety is considered as something that everybody has in the DNA, in the airline, in the organization, but also the full staff, the passenger. So of course the airline will need to build this trustable chain across its own organization, and that's why they need to communicate, they need to educate, they also need to be educated because the level of awareness in terms of cyber in the airline is very heterogeneous. So they will need to train their staff. They will need to put in place cyber mechanism, but also to make their operational practices adapted to cyber process.
So on that piece, I mean, when we talk about sort of cybersecurity issues or vulnerabilities being discovered across lots of different industries, the answer is always patch and update. Mm-hmm. So that's almost becoming a daily or hourly process, depending on what operating system you're using. For an aviation safety critical system or code, various different quotes, but it can take anything up to a year and $1 million per line of safety critical code to update it and change it. When we discover a vulnerability in aviation systems, how do we shorten this gap? How do we be more agile in the way that we update and patch? Because if there is a vulnerability in a safety critical system, then we don't want that out there for very long.
Okay. In this continuous process of cybersecurity, to augment the capacity of the industry in being more reactive, there are two aspects. One is really operational aspects. That's why we support airlines on that. You can change the procedures, for example.
And they are used to that.
And they are used to that oftenly.
Daily they are managing this type of...
So this is the operational side. And then there is the engineering, I would say, future project program design, where we are embedding technologies that avoid new type of segregation and incremental updates. And this is already partially there, because when you add a new function in an aircraft, you enter into this kind of incremental way of working. And this is one of the engineering side, this new type of virtualization and segregation. The second side is also augmenting our detection capacity by having artificial intelligence monitoring inside the aircraft or at ground level into airline operation centers. This is also
To anticipate or to give quick response.
So looking at from the complexity of the challenge that we've sort of tried to sort of discuss, certainly the first level of sophistication of attacks against something like the airline industry will be denial attacks, an adversary switching off systems or disrupting systems so they can't be used. If we look at the next level of sophistication, so where the first one might have been availability, the next level of attacks might be integrity. So we could have, if adversaries start interfering with the integrity of data on board an aircraft, then A, it's a more sophisticated attack, and B, the outcomes could be worse, because the aviation industry is used to dealing with system failures and backups and having resilience. But as well as that viewpoint from the industry of trying to make it resilient, how does it work with security researchers sort of around the world that have got different viewpoints on all of this, and how do we bring the community together in a way that we can talk about this and actually evolve, so that we have responsible disclosure from security researchers or hackers, or however you want to describe it? How do we bring everybody together to talk about this?
Mm-hmm. I can give an example. We had in 2013 a hacker raising a new risk on aircraft, and he was completely in a process of responsible disclosure, going to the authority and then to the different actors of the chain. So we learned about what was the potential risk he had in mind, and really checking, I would say, if this risk can be a potential risk in our system. And it was not only design check, but also we do what we call pen testing on the system to check that. And now this person is a consultant in the aeronautic industry. So this is an example of integration of responsible disclosure. Another example in Thales Avionics, I have a small specialist, part of the 2,000 specialists you heard by Marc Darmon. They are participating to pen test challenges, which are called Capture the Flag challenges. And because it's a great opportunity to meet both people from universities or freelance, passionate people. And it's a way to exchange, to build trust together, to have a common view of what are the new tips in hacking systems. And this is important for us to build that also.
So Stephanie, as the industry moves forward, what do you think will be to sum up, what do you think will be the biggest challenge as the industry sort of moves forward?
So from an airline perspective, the biggest challenge will be to build the trust, to make sure that the passengers are still confident to fly, and to be able to build this trust, they will need, of course, not to work alone, but to work with the full ecosystem, meaning the industries, but also the air traffic control, the airport, because their operations are engaged in many areas, and for specifically for them, they will need to put in place this continuous process of monitoring, supervising, and being able to, in case of raising emergent threats, to be able to respond quickly.
and actually we're now starting to see organisations such as the Aviation ISAC which is based in the US but global, who now start talking about and engaging with understanding what the threats are and some of the vulnerabilities. So there is now a degree of sharing which is increasing, which is good around the industry.
Yeah, there's the same initiative in Europe with EXA, which is a place where the different stakeholders, airport, airlines, avionic systems provider like us, or aircraft manufacturers will be around the table to share their small evidence of the threats evolutions.
So that's really a canter through. So I mean, it's an opportunity now for questions and see where you would like to sort of go. Or
well, I've got the two most obvious questions. One, in 2015, Chris Roberts was claiming that he hacked into entertainment systems from Panasonic and Thales, and the FBI questioned him, but was any of that true, or was he just trying to make a name for himself? And secondly, was MH370 hacked?
Get right in there.
Well, this session is called "Can You Hack a Plane?"
So
let's just go. That's it. That's the most obvious.
So I mean, I'll give a quick perspective on that. So first, if I can rephrase the first question slightly. So for me, I mean, you've heard from both Natalie and Stephanie about the efforts the industry is going to prevent people going forwards into critical systems from the cabin, effectively. Mm-hmm. So, but I think for me the bigger question is if somebody makes such a claim, when we've already got Stephanie talking about trust is really important. Maintaining that trust means being able to quickly demonstrate that systems are secure, systems can be trustworthy. That it took months and nearly $14 million to basically counter those claims. That to me is a bigger challenge for the industry, because to maintain that trust, we need to be able to quickly say this is right or this is wrong. So it may be that a security researcher has a really valid point, and it's a case of we need to build the relationships with those researchers, so that they help the industry and not just do it in a potentially irresponsible manner. And B, we need to be building systems that can be demonstrably resilient. As for MH370, some of the just things that are out there talking about that, I think it's highly improbable, and that's all I'll say.
Just going back to sort of the beginning of the discussion, we're talking about increased digitisation in pretty much all the systems around aircraft and air traffic control. Specifically with air traffic control, I understand that that there'll come a time when we start pulling human air traffic controllers out of the system. It will become more automated. That obviously has huge implications for cyber security. Could somebody just address that, and how far off is that day, or how far off is that time, and B, what are we doing about cyber security so we're ready?
Okay. So air traffic management is not my. I'm really working in aircraft systems. Do you have some?
So what I'd say is already we're starting to see an increase of remote air traffic control towers, which again, where you have some very forward-leading technology being used in an innovative way that can give some benefits. When that concept was initially built, it was built for very remote airfields, not very many traffic movements, etc. Whereas now, because the technology is becoming more advanced and normalised, we're now looking to put, in the UK, City Airport in London is now looking to be a remote air traffic control tower, which is just under 10 million passengers per year. And I think, yeah, exactly. So it's becoming a lot more normalised. So it's interesting that when you hear people talking about that sort of technology, they're talking about, we've been told it is as secure as they can make it. Okay, and you have one of those challenges there, which is, okay, so we're accepting some risk. Whether we can take that all the way to having no air traffic controllers in the system, I think that it goes back to the point of trust. Would people trust an aircraft with no pilot in the front? And it might be technically possible, but whether it's
probably
human,
psychologically not possible for a long time. But no air traffic controllers, or far fewer air traffic controllers, is obviously happening under our noses. So that's my question: is once you've taken out that human link, the system obviously becomes potentially a lot more vulnerable.
But then you get into the whole ethos of flight safety and safety management systems in the aviation industry, which is the human is normally the last link in the chain to prevent the accident. If we start removing the human from the last link in the chain, then actually what does that say for being able to catch those accidents before they become, to catch an incident before it becomes an accident?
Yeah, that's why we work on techniques like artificial intelligence to be capable on the aircraft side, for example, to capture the evolution in the behavior of the pilot, for example, or to capture evolution in standard operational flow for an airlines, things like that. And human factors is in our DNA since years. I mean, the interaction between a complex machine and a human is something that we work on for years, and we benefit from that regarding cyber, because cyber is just potentially a new cause for abnormal situation on abnormal way of working. So we are lucky in our industry to know what should be normal. We exactly know what should be the normality of flying an aircraft. I think it's the same in air traffic control. So we are building the technology so that to be capable to detect abnormal situation. And whatever the cause, this will be for the future the big investment for us.
So one of the conclusions that I put in the report was, for advice for the industry going forwards, is don't just think about securing the technology. You've got to secure the decision making in the system as well. So you've got to secure the ability for those people responsible for flight safety and safety management. You've got to allow them to make safe decisions in a timely manner in order to prevent a lot of these things happening. And that comes down to a bit of psychology and how you look at the problem. If you look at the problem as a technology problem, then you miss the bigger point that it's a system. So just to reflect slightly on, for example, the US elections, it's an error to sit and focus on the technical voting machine, as we are worried that somebody hacked the election, and you look at it's a voting machine. But actually, the system that was attacked wasn't the voting machine. The system that was attacked was the system of electoral democratic process, from understanding what the candidates are and their perceptions, being able to cast your vote for those candidates, it counted and then it announced. That's the entire system. The technology is a small element of that. And it's the same thing in the aviation industry, in that we have some amazing technology in the aviation industry, but the safety and the protections, and it's managed by the humans in the system. And we can't focus on both on just the technology or just the human. It's the whole system which is the challenge.
Any more questions? Okay. Well, the speakers will be available during lunch if something comes up again. So now, we'll just